L106C is interfaced to a computer using GEMP software, Gaertner Ellipsometer measurement program. The system is equipped with a 12-inch sample holder table. And it can handle any size samples. So the Windows XP operating system on the computer, the password is Gaertner. The system needs to be powered up and allowed to warm up for at least 20 to 30 minutes in order the laser to stabilize. I'm going to demonstrate how the machine is functioning using various in-house samples I have with silicon dioxide on silicon and silicon nitride. So these samples are used samples and for demonstration purpose and to show how the system is functioning, they are helpful. So once the system boots up, click on the icon GEMP, and this is the first screen on the measurements program. I'm going to load a sample now, which is approximately 1,000 angstroms in thickness. So after loading the sample, first the auto collimator has to be aligned. There are two crosshairs. There is a plus sign and a X sign. The lines of instruction should be aligned so that they intersect at the same point, viewing through the object eyepiece here. So in order to align the sample, there are three knobs on the stage. The three knobs are at about 120 degrees apart. There's one here, there's one on the right hand side and one on the left hand side. They can be accessed by sliding the stage out slightly, and they can be turned. So these knobs have turn rotation, and while aligning, care should be taken not to rotate a knob to an extreme end. So first turn the knobs approximately to the mid-range, about 5 turns from the ends, and then proceed to align the crosshair, viewing through the eyepiece here. There's a shutter on the polarizer side. There's a helium neon laser here, and this is the shutter. To open it, pull it out or push it in to close it. So all precautions should be taken in order to avoid staring at the laser. Once the laser bounces off the sample, it should be visible on the analyzer side here, the detector side. So there's a pinhole in this detector plate here, this bracket. So the laser should be seen passing through the aperture, only then the signal will be properly detected. So this key switch is the power on switch for the system, and there is a knob here to adjust the intensity of the lamp while viewing through the autocollimator. So after the alignment, this knob can be turned down. So to proceed with the ellipsometer operation, click on this ellipsometer image icon. Now the initial parameters could be saved. First, you can load a file and modify the parameters. So this is these are the models of the previously loaded files. Example, thin nitride, thin oxide by some previous users. So we can select any one of them, or there is a default program as well. So once we select and open it, so the system displays various parameters selected. This instrument is capable of measuring up to 4 different thicknesses and layers, and also the corresponding refractive indices and the optical constants. So after modifying these numbers here, we can always save as a recipe program, and we can recall them next time by pressing load file. So there are various options available on this machine, such as measurement modes, dual mode, and non-compensated and compensated modes. And these are timed modes also. We can select F5 and the system will continuously start measuring, and we can have the interval set in seconds. Also, there are function keys are programmed here. There are features available, such as by pressing F1, we can straight away go to thin oxide measurements, and F2 is thin nitride, and there are 2 more function keys available here. So we can, by selecting F8, we can measure and calculate. Also, the system displays last measured values of psi and delta here. And since we have aligned the sample here, I'm going to take a measurement and calculation. So either I can click on F8 or just press F8. So we can hear click the compensator moving in and out, and we can see the system already measured the delta and psi values and is displaying even the refractive index. The arms should be always at the position at the same angle of incidence, both on the polarizer side, the source side, and the detector side. Currently it is selected 70 degrees. So apart from these 3 knobs for leveling the stage, there is also a rotation wheel here which will move this stage up and down in Z axis. So it is very important to move and align the stage before proceeding to the measurements. Also, there are pinholes pre-existing on this arm here. We can locate the arms by opening the knobs on the back side here through this opening on this side. There's a knob here. We remove the knob and we can move the arm up or down. And both the arms should be at the same angle. So this is a silicon sample with silicon oxide, about 1000 angstroms. Let's measure one more time. So various other features are available, such as we can have statistics and various, by pressing F10 we can have all the data and I have enabled F10. We can keep measuring it, and so once we enable it, we will see the minimum, maximum, and the mean deviations in the measurements, in the measurement and calculation section of the display. Also, there is another interesting feature on this machine, which is diagnostics. In the diagnostic screen, we can simulate, or we can see what is happening with the machine. We can measure and store the data, or for example, we can start a measurement, and we can see it constantly keeps measuring until we press the stop button. So by clicking on return, we can go back to the main screen. Also, the cyan delta map can be enlarged, and this one is also a very interesting feature, where by moving these riders, we can see the various readings change. So this will help like a simulator to simulate the system parameters. And also there's an animate button available here. We can always go back to default location. So I'm going to change the sample now to silicon nitride and demonstrate how this system measures. So this sample I have is about 963 angstroms in thickness. Since these are all same size wafers, and the alignment is not disturbed a lot. So the nitride sample is installed, and I'm going to press function 2 to measure the thickness. So the thickness measured is about 962 angstroms. I'm going to change the sample silicon oxide, a thicker film, which is about 2,200 angstroms. So this time we use a function 1. So here in this case, we can always enter the expected thickness and measure it. So there are various features available. We can select only the thickness measurement and see how it works. So the refractive index measurements are good at about 1000 angstroms of oxide layers. That's what the user's manuals say. I also have a very thick sample, which is about 9,400 angstroms. I'm going to measure that sample. So I have to enter the expected thickness here, and then take a measurement. So the thickness measured is about 9,400. So if I leave it to the default value and measure it, the actual measured data won't correspond to the value which it is supposed to be. So various features are available on this machine to measure the refractive index and optical constants of a substrate, and also all the data can be printed on a printer which is attached to the computer. The line printer port exists on the computer, and also 2 USB ports are available along with a serial port. So in the 2-angle measurement calculation screen, which is this button, we have various data that can be entered in order to get the accurate measurement. These are the values entered before. So the ambient air refractive index is about 1, and the refractive index of the film is 1.46, and the substrate refractive index is 3.85. It is a silicon vapor, and the absorption coefficient of silicon is 0.02 negative. So the angle of polarization is selected as 45, which is also entered here. So the measurements can be taken at various parameters on the screen, and also the system is capable of simulating the readings at wavelength other than the helium neon laser wavelength. So in order to close this window, just click on this, and when the system is not being used, it is always recommended to close the laser shutter and turn off the system.